Okay, these are two photographs. Well, one's a photograph of the actual apparatus and the other's a line drawing because the photograph isn't exactly that clear, showing how the experiment was conducted. They used a very large, heavy slab of concrete and stone, and they placed it on a base of mercury. And because of the density of mercury, the mercury was down here in this, in the bottom part of this section in here, and the concrete slab floated on this, but in a very stable way, and so they could easily rotate the device, but still gave the whole experiment a great amount of solidity. So if you click on this applet here, and there'll be the applet will be in the description, a proper link to it, you'll be able to use the Michaelson and Morley. So here we are, we have the, if I'm looking at the Michaelson and Morley from on top, we have the telescope and the light source, and you can turn the light source on just by, let me get down to the bottom part. So move that up, that's better, now see. By turning the light source on, we can see the light paths as the light comes out through this, then it hits the splitting mirror, and then it is put into two different beams, and then it is detected down here in the interference pattern. And before I start doing anything with the applet, I want to point out that I've clicked on down here the expected results. So this is what we are expected to see under Michaelson and Morley's belief of the existence of the ether wind. So we start to rotate this device now by 360 degrees, and as we rotate it, here we go. If we have a look at what is supposed to happen, now up here in the combining waves, this section up here, we see the red and the blue waves are representing the two different paths that are coming along in the different directions. One is always in front of the other. So let's go back to 0. The blue wave is in front of the red wave because the blue wave's path is much shorter than the red wave. So we expect the blue to come first into the telescope, and the interference pattern is found down here. So as we rotate it, you'll see that at 45 degrees, the red and the blue wave are both got a path which is equally inclined to the ether wind. So we expect both the red and the blue wave to arrive at the same time. And here you can only see the red on top of the blue's underneath it. And we keep on going and we keep on turning it. Now the blue wave is heading more into the ether wind, and therefore the red wave goes in the front. So as we rotate it, we're expecting to see the blue wave either lag in front or behind the red wave. And that's because one path goes into the ether wind and the other path goes more across it. So just looking at the combining waves, as we rotate it a full 180 degrees, we're expecting this to go. Okay. And as a result, with the two incoming waves being in different arrival times, we should see, once again, if I do this and I rotate it around, the interference fringes should actually start to change. So going backwards and forwards, as we rotate it, we should see a total shift forward and back of the interference fringe. So that's what Michaelson and Morley expected to see. And here is the actual results. Apart from a small amount, now noticing up here that they've discovered that the red and the blue basically arrive at the same time, whether it is in any rotation. So let's say we go forward and looking again, red and blue arriving at the same time. So looking only at the combining waves at the moment, keep on moving around. every time they stopped moving the device, it all was the same. The red and blue wave arrived at the same time. Okay. So looking at that, there's absolutely no difference. There's a small difference, of course, because of the applet, but basically the combining waves arrive at the same time. And as a result, if we do that and we look at the interference fringes, nothing changes. So as the apparatus is rotated backwards and forwards, the interference pattern does not change. And this was not expected. We expected it to have a movement, but in reality it stayed the same. So what is the upshot? The result is they got a null result. So null meaning they did not prove their aim. So their aim was to detect the ether. That was the aim of their experiment. And the null result was the ether could not be detected. This leads us to the question, was this a failure or was this a success in this experiment? And after a lot of period of time, we declare it a success. Now, remembering that there were critics at the time saying, well, maybe it was not controlled as well as it could be. Was it valid, in other words? They also called into question its resolving power, its sensitivity. So, there's sensitivity instead. Was it sensitive enough to see any change because of the speed of light involved? So, these were two questions, but painstakingly, both Michaelson and Morley addressed each of these issues. And we have to declare it in the end, it's a success. It is one of the greatest null results in history. And as a result, science has changed. If we go and use this as the scientific method here, as an example, and how important the Michaelson and Morley's result is, we always remember that the scientific method starts with an observation and a problem. And in this case, the problem and the observation was the ether wind. And the ether model said that we need the ether to support light. In this case, we should be able to detect it. So the hypothesis was that the ether wind existed and is detectable. And then we come up with a very sturdy experiment to detect the ether wind, and this is the rotation apparatus with the light beams going backwards and forwards and so on. As we did this, the collection of their data was they discovered that the fringes, the interference fringe, did not change. Then they analysed why this did not change. And the conclusion that they had to come with, because of the way that it was set out, that was a very valid experiment, it was reliable, it was accurate, is that there was no support for the hypothesis. The ether wind is indetectable, which is either that the ether wind doesn't exist or it is undetectable. So using Occam's razor here, the simplest explanation is it is not existent. So we have lack of evidence now here and support for the hypothesis. Now this is important because lack of evidence for a model requires a modification to the model. So we go back now to a new hypothesis, and we need now to come to another way of trying to explain the problem that was plaguing physics at this stage. How can we transmit light in a vacuum if there was no medium? And how could this transmission be at the speed of light? That's a C, by the way. And it's going to take a person who's sitting in a small patent's office reading the results of this experiment by the name of Einstein, And he's going to come up with a whole set of postulates and come up with a new hypothesis which is going to give us an understanding of a new way of understanding light. And our understanding of light, how it changes and how it can interact, is going to bring in the modern era of physics. And with the modern era of physics, we can then understand more about the electromagnetic waves. And electromagnetic waves leads to a new theory of electromagnetism, which then sparked new technologies. And the new technologies we are now all using as a result of this. Not just because of this, a lot of other experiments as well had to occur, but it was maybe you might want to say it was the beginning of a process of total renewal in physics. Okay, so I hope that we understand how important the Michaelson and Morley experiment is in the nature of physics. Thank you.